Hey, good morning. Morning, Brianna. Hello.
Good morning, Professor.
Hey, good morning, Brianna. So you're the only one now. Um,
Yeah.
Let me quickly check um, our discussion board. And so um, it's already May 12th, and well, only one person. And then we are having Zachariah. Just joining us. So he's going to be joining us shortly. Yeah, Zachariah, and also Sorav. All right, all right. So let me move this out of the way. Oh, that's too big. 100. Okay. So in our last class, we talked about four stock valuation models, right? And the uh, stock valuation model is basically uh, just like bond valuation model. Basically, all valuation of any financial assets is basically the present value. So, in a way, it's a kind of discounted cash flow model. We have to, bond or stock or any all financial assets. Um, they they have cash flow in the future, right? In other words, they all bear fruit in the future. So the cash flows in the future, right? That's something we need to discount. But in case of stock, this cash flow is dividend. Okay, so in dividend is called the dividend discount model, right? So basically, there are four and why there are four models? Because in unlike bond, uh, in stock, the there are many multiple different assumptions that can be made about the cash flow in the future. First, so this was already talked about, in the last class. So I'm not gonna I'm not gonna repeat everything all over again. The first thing is, zero growth model. Also called, zero growth model is also, it goes by different, many different names. Um, Constant dividend. Now think about it. Growth, zero growth. Okay, I don't know if you can hear me well. Let me check my volume because okay, so I think this is better. Uh, So if the growth dividend doesn't grow, right, that means this means dividend growth rate is zero, right? Then obviously the dividend will be always constant, right? It will be constant number. And then it's also called perpetuity model. What's a perpetuity? Perpetuity is literally perpetual annuity. It's annuity that goes on forever. Annuity has a maturity. At some point, annuity stops, right? Not, exactly the bond is the case. And any installment, uh, any loan that is paid back in installment is an annuity. But perpetuity, So is an annuity that goes on forever. So in this case, the stock that pays, the stock with the dividends that never grows, that doesn't grow, in other words, so therefore constant dividend, it's like a perpetuity because it's a constant amount, constant cash flow, right? Forever. So it goes by many different names, and the formula is okay. And then second model, golden growth model, or constant growth model. Again, just because the name is constant, it doesn't mean they are the same. They are completely different. They mean the opposite things because if the constant dividend is constant, then the growth rate is zero. But if the dividend grows at a constant rate, it's growing at a constant rate. It's not, constant dividend. Uh, so they are like, quite different. And the formula for constant golden growth model or constant growth model is dividend at time t plus 1 or next period dividend over r minus g. Okay? And what is dividend in the next period? The next question is how do we know? I mean, at time we don't know what the dividend will be at time t plus 1. That's where the growth rate comes from. But we know what dividend at time t is, right? Because time t is now. We know the growth rate. We simply make it grow that way. So, and then third model is variable growth model. Variable, in other words, growth rate is growth rate isn't the same. I mean, obviously, depending on the stages of the growth of the company, right? It's also called multi-stage model. Multi-stage. Okay, but then I'm not gonna the variable growth model, although in my PowerPoint, I have summed it up, but since it's gonna take time, I'm not gonna write it out here. The fourth one is free cash flow model. Free cash flow. Okay, and this is the model to use when they don't pay no dividends, when there is no dividend. And as I said, companies don't have to pay dividend all the time. Dividend is optional. Okay, so our next question is, then how did we arrive at this final form? Right? Think about it. Just like in the case of the bond, think about it. Basically, what's going on? It's a discounted cash flow model, right? Or dividend discount model. So that means, dividend, next period dividend will be discounted by 1 plus R. and the one after the next now will be discounted by 1 plus r squared, and then so on, right? Dividend 1 plus r cubed and that ellipsis. Now, we're talking about zero growth model or constant dividend model, so we don't need time subscript for the dividend because next period. Please mute your microphone if you're not speaking to me. So dividend at time t plus 1, dividend at time t plus 2, t plus 3, it's all different. It's all the same. So there's no need for time subscript here because they are all, the same thing, right? And then, so if we keep going, basically, stocks don't have any maturity. It goes on forever. So eventually you will hit the point. I mean, there's no end, right? But, how do we express how do we express the timeline without any end? Of course, infinity, right? So basically, there will be dividend paid at infinity minus 1, infinity minus 1 period. And there will be dividend paid at infinity. Of course, this is just a thought experiment because by definition, infinity is not something you can nail down, right? Infinity is not something you can nail down. But if we can, if we express it, at least, how do we express it? Well, we'll have to express it like that. And at that point, at that infinity point, there will still be a price of the stock at that point, right? We don't know what it's going to look like. Oops. We don't know what exactly it is, but at least we know that there will be some and this number, some price of the stock at that infinite point in time. But now let's think about it. What kind of number will it be? What kind of number? I mean, just you might think, oh, it's in the infinite future, so it must be an infinitely large number. Huh? This must be an infinitely large number, huh? You might think. No, but the answer is no. The answer is no. It's not going to be an infinitely large number. It will be a finite number. Why? It will be a finite number. And why is that? Because think about it. Stock prices do not just balloon, infinitely. Why? Two reasons. One, because of two reasons. One, stock splits. And the second, business cycle. Now, I've been telling you the reasons. With Apple, I explained this before. Some so Apple started out back in 1981. That was the I don't know exactly what month, but the IPO was in 1981, and at the time, I told you the IPO price was something like $10. But now, if you look at the data, if you go to Yahoo Finance and look at the data, it looks as if Apple was 10 cents at the time. Well, why is that? I told you, because there has been splits along the way, right? Apple has like 40 years, 41 years. Apple is 41 years 41 years old this year. And over 40-year life of Apple so far, Apple has gone through at least 7, 8 splits. And after each split, right? So, and I told you recently there was a 4-to-1 split, 4-to-1 split in August of 2020. It was 4, and then prior to that, in 2014 or 2000, I believe it was in 2014, there was 7-to-1 split. Now, before 7-to-1 split, Apple was like $660, and then after 7-to-1 split, you divide 660 by 7, you will know what it's going to be. It was like 90 something dollars or 80. Let me just quickly. 660 divided by 7 comes to $94, right? So so then think about it. You adjust pre-split price to be to align with the post-split price. So after the split, the price was $94, and then pre-split prices cannot show as $660. It would be adjusted or prorated to be aligned with the post-split price. So then, whatever the price was, 650, whatever, they were all, real prorated. So that way, if Apple had like, tenths over, 40 years, that explains why the IPO price shows as $0.1 or 10 cents now. But once again, if there was no split, since IPO, Apple grew. I've been telling you, since IPO, Apple has grown almost 1,300 times. 1,300 times. So if Apple never split, if Apple has never split, and just let the price grow at this rate, $10, when it started as $10, think about it, times, right? It grew. What did I say? Almost 1,300 times. So then, it should be now $13,010 today if there was no split. Now think about it. If Apple is $13,000, is it marketable? Is it going to be marketable? Anybody can anybody answer that? If Apple is $13,000 today, can it be easily traded? Anyone? I have like 8 people here. Can anyone answer that question? Nobody can answer that question. But do your exactly, Samira? It can't, right? Okay, Samira, you got Samira, you got 0.5. Because it's too burdensome, it's too onerous to buy Apple and even selling it. Because if you have, that means if you have only if you have something like $15,000, you can buy just one share of Apple, and then even selling it, uh, uh, buyers would find it very onerous to. In other words, you can buy 130 shares of $100 stocks, right? With that money, you can buy 130 shares, right, of $100 stocks, and then liquidate a portion of that and keep the rest of it in Apple's. So in other words, that's the reason for split, if to make the stock more marketable. And the second reason is business cycle. Now think about it. The stocks lost, Nasdaq lost, almost 40%. I mean, since my portfolio lost, almost, 12% from the highest point, and the highest point was like, January 3rd of this year. And since from that point, Nasdaq alone lost almost about 40%. So we have business cycle, and through these cycles, right? Think about it. Although, or in the long run, it may have this upsloping trend, but the prices cannot just grow indefinitely, right? Because of this ups and downs, right? Even in the infinite future, please say it. I cannot, constantly come back to this while I'm on the whiteboard. Unmute your mic. It doesn't work. Okay. Oh, I'm sorry to hear that your portfolio lost 62%. um, I part of my I have my own brokerage portfolio, my own investment portfolio, and then there is my retirement portfolio. And my retirement portfolio is not, I cannot touch my retirement portfolio. It's managed by some, a fund asset management company, right? So, but my brokerage portfolio alone lost about 40% since the highest point. And I'm my brokerage portfolio is mostly in Nasdaq and ETFs, not individual. I have some individual stocks, but mostly ETFs. So based on that, I can tell Nasdaq on average, probably lost somewhere near 40%. But anyway, because of these two reasons, right? The future value of this, right? A price of stock at infinite future, it cannot be an infinitely large number. It's a finite number. On the other hand, we know this is infinitely large number. Why? Any number greater than 1. This is greater than 1 because, 1 plus r. Even if it is just 1.1, raise it to infinity. This will be an infinitely large number, infinity. So think about it. If you discount this by any finite number, if you divide a finite number by an infinity, it goes without saying it's going to be close to 0. So this term is irrelevant. We don't have to worry about this term. That's why it becomes dividend discount model, right? That's why in case of stock, the discounted cash flow model is called dividend discount model, because we are dealing with basically just dividends. So now let me call this equation 1, right? I will call this equation 1. And then I will multiply equation 1 by 1 plus r. And I'll call this equation 2, right? Equation 2 is basically multiplying equation 1 by 1 plus. Okay, this is equation 2. Then the equation 2, what's it gonna look like? So we know what's it gonna look like because everything must be multiplied by 1 plus r. So left-hand side will be 1 plus r times v0. The right-hand side is going to be dividend. Why? Because you multiplied 1 plus r. 1 plus r will cancel out. And then this term becomes dividend over 1 plus r, because multiply, I don't think I need to write that, because if I have to write it to make you understand, then it's a pathetic situation. Multiply this, they cancel out. Multiply this, right? And so third term becomes then dividend over 1 plus r squared. And if we keep going, this term becomes dividend over 1 plus r. Raised to infinity minus 2. And then there will be, this term becomes 1 plus r infinity minus 1. But we will still have, because infinity is not a determined point. It's not infinity. There will still be dividend at infinity, right? So 1 plus r raised to infinity. Now think about it. And then what I'm going to do is I'm going to subtract equation 1 from equation 2. So I'm going to do equation 2 minus equation 1. And if I do that, what's going to happen? Think about it. If I, so the whole thing will be negative. The whole equation 1, oh God, I have to make it smaller, maybe. This whole thing becomes negative, right? Because you're subtracting it, okay? So then if I subtract, so what's gonna, the left-hand side will become now, the left-hand side will become 1 plus r minus 1 v0. That will be the left-hand side. Isn't that right? Why? Because it's 1 plus r v0 minus v0. So if you factor out v0, you factor out the common factor v0, it's going to be 1 plus r minus 1. And then, of course, 1 and minus 1, they cancel out. It becomes just r times v0, right? And in the right-hand side, this term and this term will cancel out because this minus this term and this term will cancel out. This term and there will be a matching term there. There will be a matching term there. This cancels out with this. So eventually, in the right-hand side, you have only dividend left. So if I rewrite this, it's going to be what? R times V0 equals dividend. Now, this is our unknown, right? Isn't that right? V0 is the unknown. So if you're solving for V0, now you all know if x times y equals z, right? I've been telling you, the key to solving any equation is identifying this structure, right? And then if x is the unknown, z divided by y, right? So here, oops, this is x, this is y, this is z, right? So solving for v0, right? I don't have to rewrite it here. And therefore solving for v0, dividend over r. So this is how you got to that end result, right? The reason I'm talking about this is I've been telling you over and over. Textbooks generally just tell you, just throws these formulas at you, and you are supposed to memorize it. You may memorize it for a while, you may remember it for a while, and then after the exam, you forget all. You just forget everything. Why? Because you just memorized it by rote, not like understood why and how the end result is like that. Why and how you arrived at that end result, right? So that's one reason, I'm showing you the steps of derivation, because if you understand the steps of derivation, you don't have to memorize it. You can derive it from the scratch, right? Now, so that's why a zero growth model looks this way, and as a zero growth model example is really pathetic, actually. So here, Chuck Swimmer estimates that the dividend of Denim Company, an established textile producer, is expected to remain constant at $3 indefinitely. Now, as you read the problem, the verbiage of the problem, you should be able to sort out which one is fat and which one is meat. In other words, which one is nothing but frill, useless frill. Or, first of all, the names like, do we need names like this? Chuck Swimmer. I mean, we can just call him Mr. A, right? Doesn't really matter. Denim Company, name doesn't matter. You can call it Company X, right? Whether it's a textile producer or not, it's also not very relevant, but okay, whatever industry it may be, does, established. It's an adjective. Does the adjective matter? Does the adjective or the adverbs matter? Yes, they matter. That's the interesting thing. Usually, adjectives and adverbs. You think they belong to the realm of the literature, poetry, right? Something like, oh, how grandiose, oh, how glorious, blah, blah. Those adjectives are useless adjectives. Those adjectives are really, nothing but frill. But, established, and the adverbs like indefinitely, they count. Why? First of all, indefinitely means, oh, remain constant. Okay, so that's going to be a perpetuity, right? It's a clue that it's going to be a perpetuity, right? Or zero growth model. And established has and mature company. Established company means mature company, and paying constant dividend, and mature company, that they coincide with each other, right? Why? Because a mature company doesn't grow. Mature company has almost no room for growth. Okay, this it's gonna take a lot of time, but why is it mature? When you are mature, you don't grow. So mature company means market share. In terms of market share, like Coca-Cola, how much more can Coca-Cola grow? In geographic market, of course, if they launch a completely innovative product, yes, it's got a lot of room for growth. But just look at the regular Coca-Cola, as far as that. There is nowhere in the world that Coca-Cola hasn't reached, right? The only probably only North Korea and probably some countries that are ruled by Al Qaeda or Taliban, because they hate America and they hate whatever represents America, or American capitalist system. So even Russia, McDonald's was first McDonald's in Russia was in 1991, after the fall of the Berlin Wall. So look how much but it's not like that. It's not 1991, and pretty much there is nowhere in the world that Coca-Cola hasn't reached. Even Antarctica. Even in Antarctica, you might wonder, why in Antarctica? I mean, are there any people in Antarctica? Yes, there are research bases, right? Research bases like, USS research base. UK has research base. South Korea has 2 research bases in Antarctica. Argentina has, of course, research base there. France, Germany, I guess, all have research bases there. And those research bases, scientific research, right? They would have vending machine. They would have to drink Coca-Cola. But so other than North Korea, who deliberately ban anything, that can be a symbol of capitalism, or Al Qaeda, or Taliban, they will hate anything American. So other than those parts of the world, and they are banned, they banned it. So geographically, there's no room for Coca-Cola to grow, right? That means revenue cannot grow, and if the revenue cannot grow, profit won't grow. If profit won't grow, they cannot pay growing dividends. So anyway, so even these adjectives are clues, right? Those are the clues. So then, perpetuity model or zero growth model. So then, we use this formula, $3 dividends, uh, required return on the stock is 15%. You divide it by R, so the price should be $20. Then next, we have only 7 minutes left, but next question is, so where did you get, how did, then Gordon growth model, how did they end up in this form? How did they end up in this form? How did it end up in this form? So actually, to explain that, I'm gonna have to use actually the illustration, or the steps of derivation can be found in topic 5. Actually, I have only like 8 people or every time. So here, you may have not noticed, but okay, here. So Gordon, these steps of derivation of Gordon growth model. Okay, so first of all, PT is price at time t, so it's like V0, and 1 plus K we know it's cost of capital, so it's required return. Cost of, it's in case of stock, required return is the cost of equity, right? So it's like one period growth model, right? But then the difference between this is, as I said, return, and there's a difference between return and growth rate, but they are the same thing under certain circumstances. So here, let me put it. You remember from our topic 1, we have scenario 1 and scenario 2. And what are scenario 1 and scenario 2? So scenario 1 is basically, when you, it's like a zero coupon bond, right? Like zero coupon bond. and it's like coupon bond. If it is stock, but if it is bond, if it is stock, this is no dividend, paying no dividend, stock that pays no dividend. This is dividend paying stock, right? And you remember, in scenario one, future value will be, let's say, price at time. Price at time t plus 1 is just price at time t times 1 plus r, right? So in other words, this is the same thing as growth rate. This is the same thing as just growth. In other words, remember in case of zero coupon, there is no interest payment. So basically there's only capital gains, right? And remember, if you buy a house and do not rent it out, there's no rental income, but just, then there will be capital gains or capital loss when you sell the house, right? I mean, if the house value appreciates, there will be capital gains. If it doesn't, if the house value drops, then you will have capital loss. So basically, in that scenario, return is the same thing as growth rate. However, in scenario two, return and growth rates are different because when you buy the stock at time t, and it in the next period at time t plus 1, it pays not only it grows into not only pt plus 1, but it will give you dividend at time t plus 1, and that's the return. And since topic 1, I've been making these I've been emphasizing these differences. The difference between the growth rate and return is the growth rate is the same thing as return in under scenario 1, but they are two different things in scenario 2. Now, so think about it. Return will have to be greater than just the growth rate because it will have to include also the dividend. Okay? Now, if you understand that, and think about it, if you understand that, if I, so since we don't have much time, let me, now, so let's solve this for, if I want to solve this for, eventually I'm going to solve it for PT, but, let's rearrange a couple of things. So if I divide both sides by PT, the right-hand side will be just 1 plus k. The left-hand side will be pt plus dt plus 1 over pt. What is then, pt? By definition, pt is the result of the growth from pt. pt plus 1 is basically, right? So, right? And then we can break it up because, when we have, this is, it's like PT, we can break it up like this, plus and again, this can be broken up, but PT and PT will cancel out, so it's going to be 1 plus G, and then right? And then we collect the like terms. So we move it to the right-hand side. 1 and 1 will cancel out. And, when it's moved to the other side, the sign will change. Therefore, uh, and in the left-hand side, we have only this left. And we know if we solve it for pt, then it's going to be dt plus 1 over r minus g. I mean, it's k minus g, cost of equity. But, that's the required return, the discount rate. So hence we arrive at Gordon growth model. Okay? So that's how Gordon growth model was derived. And then that's the so Gordon growth model is literally one period model. So we come to dt plus 1 over r minus g. But again, we know dt plus 1 is the result of dt times 1 plus g, because we don't know this. This is the unknown, but we can forecast it because we know the growth rate, right? So Gordon growth model is really one period model. One period model. One period model can be again extrapolated, and it can be extended into a multi-period, but it's just like connecting each period, making one period projection, and then from there one more projection and one more projection, and that way we can do even multi-period. But it's basically a one period model. So that's how these formulas have been derived. And once you know these formulas, then variable growth model is just an application of Gordon growth model, and it's an application. What's going on? It's an application of Gordon growth model, and then free cash flow model is also an application of variable growth model. Okay, so all right, that's it for today. And I don't know if I can cover everything. It's pretty much impossibility. But we have our last class will be next Tuesday. Everything has been already covered by the main lecture, but hopefully we won't be able to cover. That's for sure. We won't be able to cover return and risk part 2, but that's also has been covered by the main lecture. So that's all. That's all the time we have. Any questions? Any questions? All right. Even if you have any questions, I don't think I have time to answer that. So if you have any further questions, please, you can, send me an email. All right. So class dismissed. Have a great afternoon, everyone, and I will see you next Tuesday. All right. Okay. So.